Okay, can everybody hear me?
Loud and clear.
All right, we've got 61 participants, so I know some will be coming, but I just want to bring everybody up to date on what's going on. The provost's office got involved with this course and did some investigations, and they found quite a few things that were unsettling. One of them was, I've just copied something that is an excerpt from Associate Provost Emmett Swin's message to me. I'll come forth with a longer message. We're going to go back to meeting, having quizzes in person. There were some problems and some falsification of information and other things. And well, I'm not going to say anything more about this because frankly, I don't know what's going on with that. Anyway, the bottom line is this, that we will go back to in-person, or to, I'm sorry, quizzes and tests in the Brown Koppel Center. Now, about Monday's quiz will be online because it was announced as such. And I got a ton of email and comments and other things in the last 24 hours that I did not expect, and I'm sorry if I haven't responded. But I'll bring you up to date on this. On Monday, at the end of class, this will be the last 30 minutes approximately. You'll be sent a quiz, and you'll have approximately 30 minutes to turn it in. Now, that means you're going to have the ability to do it on paper, and I'll be very clear that what I want boxed in the answer form. There'll be, it'll be a more involved quiz. As I've said before, it's not going to be ridiculously hard, but it'll be of the order of the more difficult problems, if that makes sense to you. And I don't have a lot of information about it since I haven't made it up. But what it'll be is something that is going to require you to do this. Now, I know because there have been a lot of reports of cheating, and I've even caught some people. There may be at least 2 different quizzes. There may be other things involved that would try to eliminate that. This is going to be something that will be open book, open notes. So the level of difficulty is going to go way up. Very little partial credit too. Now, some people are going to, complain about that. There's really nothing I can do. It wasn't my doing. I'm sorry about this. But then the upcoming Friday will be in person, and it will be up in Brown Koppel. We'll go back to the standard format. And if you have further comments or questions about that, save them for until the class is over in the office hour. Now, I've got a bunch of questions about problems. So I'm going to address those that are pertinent to the class. And I'll give everybody a piece of advice. Focus on understanding the material and knowing how to do the problems and not worrying about how difficult they are or anything like this. Because if you think about it, the problems I'm going to give you are no more difficult than anything in the book. However, in the book, for you to do some of them, it requires you to have a fair amount of understanding. And if you see it and understand it, it won't be a problem. There'll be possible multiple circuits, not just one circuit. And it will be an issue where you cannot spend time reading a book, looking online, or chatting with your friends. It won't do you much good in this case because it is going to be timed. And if you miss the time constraint for whatever reason, then you're probably going to get 0 credit. Now, I hate to say that because there may be technical difficulties. What it means is at least 5 minutes before the quiz is due, you should upload it. And it's going to be made out for 15 minutes. More about that later. Now back to the actual coursework. Sorry I had to get long-winded about that. I didn't want to. I didn't realize I get so much email from everybody, including the administration. And I don't know what's going to happen. I don't know what this, I'm not even going to worry about that. All right, and last time apparently I don't frankly know what happened. It wasn't recorded. The audio was recorded, but the video wasn't, unless I don't know it. Did anybody see the video of last lecture? I got an audio recording, but I didn't see the link to the video, so I don't know what happened. This one says recording on my screen. It is recording, and I apologize. And frankly, I don't know what happened. Okay, now back to this. I got to get the document camera up, I hope. Hope that works. Okay, it does. And then I got to share the screen. I hope this works. Can you all see the screen, class? Okay, good. And then I'm going to try to spread y'all out so I can see as many of you as possible. And if somebody knows how I can resize this to get more of you in there, just let me know. And chat doesn't appear here, so instead of chat, turn off your mute and tell me if you know how to crunch down the actual size of these Hollywood Squares people so I can see more of you. But I'm not really focused on that. I got questions about homeworks. Now, the first one, was it 252? Can somebody just clarify or confirm that? Anybody?
Yeah.
252. All right. I'm going to draw it up here first. Everybody see that? Didn't we do this one, class, or am I wrong? Did we do it or not? Do you remember?
We did do this one.
It's all right. We'll go through
But
it
it was
again.
in office hours.
Yeah, I think it was an office hour.
All right. And I apologize if you didn't see it, but whoever asked that, I just want to go through this with you. Now, the key is this is grounded, right? That's 0 volts. I'll draw it if I have to. Y'all with me on this? Let's see if I can make that straight now. I'm sorry if it was an office hours. Now, at that point, if you take a look at this, there's a couple things we know. First, we know V2 is 6 volts, and I'm going to draw it right there because I've got it. Y'all see how if this is 0 volts, this is 6 volts, right? I mean, give me some kind of confirmation. If you can turn your videos on, put them low res, I'd appreciate it, just so I can, or have some way of giving a thumbs up. Confirmation helps me. Y'all with me? Yeah. That's 6 volts. The next thing I can see here without, and I haven't written it on my paper, but y'all see how V1 minus V2 is 12? Right? Y'all see that, class?
Yeah.
Now, what do you know about V2? What's the value?
6.
6, right? So what's V1? Y'all agree with that?
Yes.
How many do? I'm not trying to go fast. I just want to make sure we're on the same page and there's no mystery here, right? I'm not seeing a whole lot of agreement. I got about maybe 25%. I hope y'all can see this. If you can't see it, then let me know, because most of you have your screens blanked, so I don't know, but just let me, I mean, it's coming across, right? The video and everything, right?
I don't know about other folks, but my connection is really spotty, and so it's just frozen on your hands holding the pen.
Who is this?
This is me, Bonnie.
Where are you?
I live off campus.
Are you, I mean, is it Spectrum, or is it, what internet provider?
Yeah, it's Spectrum.
Do you have the lowest level service?
I have no idea. It's just what my apartment provides, so probably.
I apologize. Can you see, and I'm just asking this question because if I cannot do anything about your apartment complex's internet, but can you see V1 minus V2 is 12?
Yeah, okay, yeah. The video just fast forwarded to that.
Can you watch the videos when they're online?
Yes, sir.
Hopefully they will capture everything, okay? Now, do you all agree that this is V2 is 6 volts? Do you see that, Bonnie? This is one of those things that's happened to me before. It's very awkward talking to people and they not hearing you. Bonnie, are you still there?
Yes, sir.
Okay, do you see V2 is 6?
Yes. Yes.
Do you see V1 minus V3, pardon me. That's, can't read my, this is V1 minus V3 is 12 would be one equation. I'm sorry, I put V2. V1 minus V3 is 12, right?
Mm-hmm.
Equal 12. If that's what was in chat, thank you. Right, so that's another equation. Now the rest of that, since this is V2, then can't we just label the currents? And I did this before, but you can call that I1. It doesn't matter the designation. You can call this I2 if you want. Doesn't matter what you can call it. You can call this I3 right here, right, class? I mean, it's through the 1K. I
Can
mean,
you zoom a little bit?
can't hear you.
Can you zoom in a little bit? Yes. That's better.
With me? Whoever asked that?
Yeah,
Okay.
that's much better.
We did this before, but that's I3. I don't care what you call them. Can you agree with me that this is I4? And again, it doesn't matter what you designate them as, right?
Yes.
Give me a thumbs up if you follow me. I need somebody to tell me they can hear me and understand, right?
Right.
All right, just,
Yes.
all right, now, and then down here, you can call that I5, but it doesn't matter the designations. Again, I'll say that. A, B, C, D is fine. Whatever you choose has to be unique. Now, once we know that, now the thing is, what do we see right here that is the gotcha? This is the supernode, right? It's a voltage, sorry, up here. That's a voltage source between what? Two nodes right there. It shouldn't be down here. Do you all agree with that?
Yes.
Yes, sir.
Now, and the rule is if you have a supernode, it's a voltage source between two unknown voltages. Correct, everyone?
Right.
All right. So all the currents into that equal all the currents out of it. Do you all agree with that?
Mm-hmm.
Yes.
All right. I'm going to just ask you this. We've got V2 already at 6 volts. We know that V1 minus V3 right here is 12 volts. That's two of the unknowns, sort of defined, two equations, agreed?
Right.
Then we have what? What flows into the supernode flows out. Well, what flows in? If you look at the way I've designated, I1 flows in, correct?
Right.
Mm-hmm.
It's just arbitrary. Everything else is flowing out. What's flowing out? I2, I4, and I3. Do you agree with me?
Yes.
We can write those equations in terms of the unknown voltage. So that's the second or third equation, if you would. Then the next equation you need is right here, right here. And that's all the currents into this node are equal to all the currents out of the node. What's flowing in is I4 and I3. What's flowing out is I5. Agree?
Mm-hmm.
If you do, just thumbs
Yes.
up. Now, for those who asked about this specifically, it is in the office hour on, was it the last lecture? Whoever told me that? Or was it the lecture before?
I think it was the last lecture.
All right, just check the office hour. But we did this one, and basically it's setting up a system of equations, correct, class? It is a 3x3, isn't it?
Yeah.
All right, now you're not going to get a 3x3 on the quiz or test. I've said that, I don't know, 4 or 5 times, correct, class?
Yes.
Yeah.
And since you're not going to get that, I'm not going to do it right now. But for the person who asked this, if you want it done in its entirety, I'll be happy to do it in the office hour afterwards if you are unable. Did this help whoever asked this? Okay. What I'm really telling you is the key to this is the supernode. Do you agree with me, everyone?
Yes.
And,
Yeah.
and that's the key. The supernode is a voltage source between two nodes of unknown voltage. Everybody with me? Okay, other questions regarding the homework. And if you couldn't make the office hour, try to watch it. It's sometimes these questions in the office hour are much better than in the regular class. Class? Anybody else?
I have a question about that supernode. Sorry, I must have missed it.
That's all right.
So I know that the supernode is like that source between two unknown.
A voltage source, a voltage, not current, voltage source between two unknowns. Now, here's the reason why it exists, and I want you to pay attention to this and listen to me. Normally, when we do currents, can you see what I'm pointing at right here?
Yes.
All right, normally, if we think about currents, we take the voltage on this side, which would be V1, minus the voltage on this side, which would be 6, divided by 1K, that would define I2, correct?
Yes.
Here, if you try to get currents, what happens? I got V1 minus V3 divided by what?
There's no resistance.
There you go. So in that case, you have to make a supernode, and the supernode is just extending the nodal condition or the fence where the node is to include the voltage source. Everybody got that?
So you'll treat it like a regular node where all
Yeah.
the in equals all the out. Fantastic.
That's always the case. Got it, everyone? They use the term supernode.
So you treat that whole, like that T of the
This,
circuit as like
well,
one
it's
big
the
node?
purple fence I put around it.
Yeah,
Here's
purple
the
fence
these
is-
two nodes. You just put a fence around it that includes the voltage source. Good
Okay.
with that?
Okay. Thank you.
Okay. Got it, guys? And there's, if you look online, there's a ton of supernode, it just looks nodal analysis, supernode problems. You'll probably see a cajillion of them at MIT and Stanford and Penn State and Illinois and Georgia Tech and probably at Auburn. I mean, there's probably tons of stuff online from Irwin and Nelms. But you can dig up more problems you know what to do with. Okay? All right, next question. Other things, like about Thevenin.
Yeah. Can you do 2.75 from the almost
2.75. All right. Now I'm going to redraw this one. And if you don't mind, I'm going to zoom out. Can you all see this? And just for those that have their video on, how many are okay with the video speed and they can understand me and see me without a lot of problems? If you can, just I need an affirmation here. All right. And if you have problems, let me know, because if I can do something about it, I will. But I want you to know I cannot do anything about a slow internet provider. That I found out the hard way by trying. Hold on for 1 second. I don't know. This is one of these awkward moments. Chat. I don't have any idea where chat is, but it's not showing up, so we'll just leave it alone. Okay, so you want 2.75. Let's talk about this first. We're going to use Thevenin. Thevenin's a very good, and this will be included on the quiz, all right? Because we're covering it now second day. Everybody with me on this one? Now follow me on this. For Thevenin, what is the load resistance? Just tell me.
4 ohms.
4K
Ohms.
ohms. 4,000 ohms or 4K ohms, right?
Yeah.
Everybody see that, class? When I say this, whatever the unknown voltage or current relates to, that resistance is the Thevenin, the load resistance, right, class? Are you with me? So the first step is identifying, which we have. The second step is removing it, correct, class?
Right.
How many got that?
Mhm.
All right, so I'm removing it, and I'm just going to go down here and put 2.75. And I'm going to put my first step, RL, is simply equal to 4K ohms.
Move your page down.
Yes, thank you. And it will sharpen up in 1 second, I'm sure. I hope.
Do you mind explaining again why the 4 kiloohms, like how you know that that's the load?
Sure. As a matter of fact, if somebody else wants to jump in and help me, it's fine. But you see how this is the unknown we're looking for, V naught in blue, right?
Yeah.
You see it as a cross or in parallel with the 4K, right?
Mm-hmm.
Therefore, that's the element the voltage is developed across, right?
Okay. Okay.
And therefore, that is the load. So you
Gotcha.
remove it. Got me on that one, class?
Mhm.
Now I'm going to redraw it without it. So without it, it looks like this. There's the first thing. Now I take it out and I redraw it. And here, that's 12 volts. That's 2K ohms, right? Then I've got, did I do this one? For some reason, it's deja vu. Didn't I do this one?
Yeah, you did this one already.
That's all right. We'll do it again since obviously some people kind of missed it. That's okay. So this now is where that load resistance was, right, class? We'll go through it. Y'all with me? I mean, it helps because I don't know if this screen locks up or not. Y'all got that, class?
We got it. Thank you.
All right.
Yeah.
So now this is where it was. So therefore, this would be the open circuit voltage right there. Correct, class?
Right. Yes.
Right? And I mean, I could put this 2K on here. There is a 2K also here. But why isn't this one important, class? Anybody?
Because the current wouldn't flow that way since it's open.
Right. This is effectively a capped pipe, and current is like water. Nothing can flow. So that means the current here is 0, and that means the voltage is 0 across there. Correct, class?
Yes.
Effectively, it's a straight wire, isn't it, class?
Right.
All right. So what I'm looking at is VOC. Now pay attention to this. Make sure everybody's paying attention to this. You see that we've got 2 milliamps here, correct? How much of that
Right.
2 milliamps can flow this way?
None.
None. All of it flows this way, right?
Correct.
So if 2 milliamps, like water in a pipe, is flowing that way, what is the voltage across that 2K?
4 volts.
It's 2K ohms times 2 milliamps or 4 volts. That's important to see. Y'all got that? It's very
Yeah.
obvious once you take a look, right? Now, once you have this voltage, we can get VOC, and I suggest you do it this way. I tell people this, and if you listen to me, you'll be fine. When I want the voltage where I have a plus to minus, I start at the minus terminal. Got it? Now I go this way around. I cannot go this way. Can anybody tell me why I can't go this way? It's a single fact. You don't know anything about the voltage across that current source. You just know the current, correct?
Yeah.
Everybody follow me? It's like you know the flow rate, but not the pressure differential for the UMEs and aerospace engineers, right? So you can't go this way. You have to go this way. So this would be a voltage what? Increase or decrease, class?
Increase.
Increase of 12, right? And then when I hit here, it would be a voltage increase or decrease?
Increase.
Increase because I came to the negative and left the positive. It's going up by 4, right? Or that's 16 volts, correct, class?
Yes.
All right, that's the open circuit voltage. That's the second thing you need. Now, the third thing you need is R Thevenin, right? I'm going to go through it again. Y'all remember this, right? What is R Thevenin? It tells me what the input resistance is looking this way from where the load resistor was. But in order to do that, I have to do something. I have to make the current sources go to 0, or they become open circuits, right? And I left the voltage sources to go to 0, or they become short circuits, right? Now, when I say short circuits, that's 0 ohms. When I say open circuits, that's infinite ohms. Correct, class? I mean, give me a thumbs up if you got that down. Are you with me? Right?
Yes.
Can you move the
Yes.
paper to the right? Or sorry, to the left?
To the left, like this?
Yes. Thank you.
Sorry, y'all see it? All right, now, let's go and do that. What does this become? An open circuit, right? It's as if it's torn out of the circuit entirely, isn't it, class? How many see that? What about this? What does it become? Class? Short circuit, 0 ohms, right? Just a piece of wire between the two things, isn't it? When you turn off a voltage source, there's no voltage. It's a short circuit, isn't it, class?
Yes.
Everybody got that? This is real important. Now, if that's a short circuit and that's an open circuit, and I want the resistance between here and here, what is it? R Thevenin would be what? Start here. Look, what do I see? I see 2 kilo ohms, right? This doesn't matter, does it? It's taken out of the circuit. It's an open circuit. Just rip it out, right? Rip out that current source. With me?
Yes.
But when I go here, I see another 2K, right?
Right.
That's 4K in series. What about here? That's a,
0.
yeah, short circuit or 0 ohms. Back to the negative. So R Thevenin is 4K. Do you all agree with that? 4K ohms.
Yes.
So when calculating your resistance, you go around from the positive to the negative
Or
term?
the negative to the positive. We're just finding out the equivalent resistance between the negative and positive terminal
Okay.
when you short out the voltage sources and open the current sources. I like to say take the current sources out of the circuit and replace the voltage sources with a straight wire. Good? All right. Now, the final thing is assembling the circuit, the final circuit. So the Thevenin equivalent of circuit without the load resistance looks like this. You start with the open circuit voltage. Sometimes this is referred to as V Thevenin. And that, in this case, is 16 volts. Then you put the Thevenin equivalent resistance seen from the load. And that happens to be 4K.
Can you scroll down a little bit?
Yeah, okay. 4K ohms, right? Now, here's the point. These 2 points here are where the load is connected. You realize the load had no bearing on any of the prior calculations, right? And what we did is take a circuit with several components. What we got? 4 components, reduced it to 2 components. A voltage source and a resistance, correct, class?
Right.
That can be done no matter how many components are there, as long as it's a linear system, a linear circuit. And that's the predominant type of circuit you'll be encountering in the real world, more or less, with some exceptions. But anyway, what that means is this. I can take, if I'm just worried about different loads, and this is a typical kind of test question too, I'll give you this. And I'll say calculate, and I don't tell you how to do it. Calculate the current through a load here when the load is 4K, 1K, 10K, and a short circuit. So some people will write systems of equations 4 or 5 times. That's a pain in the butt. Takes forever. You'll burn out. The smart kid that knows how to use Thevenin's circuit, they do this, and it's trivial, right? At this point, what is the current? Just put this as RL. And I want this current I, or this voltage V0, doesn't matter. Well, current I is what? It's equal to 16 over 4K ohms plus RL, right? That's one equation. I stick one unknown in there, RL, bang, I got I. Change RL, bang, I got I. I can do that as fast as you can imagine on your calculator. I can make, as a matter of fact, I can make RL a vector. This will be a vector, and I can get the answers very quickly. So what I'm pointing to you is the utility. I'm trying to point out the utility of using Thevenin's to solve problems when the only thing you're going to do is, the only thing you're interested in is the current or power delivered to a load resistor. Got it? Now, while I'm on that topic, I'm not done yet. So now I can find out when RL, in fact, is 4K, right? Because that's what it was. Correct, class? When it is 4K, what is the current, class? Well, 16 over 8K would be what?
2 milliamps.
2 milliamps. Do you all agree with that? Right?
Yes.
All right. Now, if that's the current, how much power is being delivered to the load? Well, the power is what? It could be V times I, right? Voltage across the load times current across the load. They actually wanted V0. What would V0 be? Anybody? Anybody want to just hazard a guess looking at this 4K, 16?
Two.
Come on, think about it. 4K and 4K.
8.
Well, this would be the 16 volts, right? Divided by the voltage you want, the resistance you want the load across, which is 4K, over the sum of the two, or 8K, right? So that would be what, class?
8 volts.
8 volts. Now, what's another way to get it? This RL is 4K, right?
They're both the same resistance, so they're going to drop the same amount of voltage per
That's
resistor.
correct. You're absolutely right. Here, I wasn't going for that, but you're absolutely right. And you should be able to see that. For those of you who are doing problems, that's you're good to see that, make that observation. But this is 2 milliamps, right? What's the voltage across any resistance if you got 2 milliamps flowing through it? the resistance times 2 milliamps, right? So 2 milliamps times 4K is 8 volts, right? Another way to get it. You with me? How many see this? If I'm talking fast, it's because I'm trying to get through the material and it seems rather obvious. Now, the power in the load resistance is V times I, or it's V squared over R, or it's I squared times R. Do you all agree with that, class? That would be in watts, right? Not in horsepower, watts. Mechanical engineers are going to go nuts in thermo with unit conversions. If you haven't had thermo, wait until you have it. I don't like BTUs. Just telling you. How many has had thermo? God bless you. You poor people. I don't know why they don't go to MKS, but they don't. It's something very personal, I guess. Anyway, here's what I use. If I got a resistor and I want power, I take I squared R. Almost always. Got it? Yeah, that's true. V squared R works, but this is no problem at all. I don't even think about that. If I know the current through it, it's a gimme. It's I squared times R. I is 2 milliamps, right, class? Let's see what the power is. Well, I got 2 milliamps, right? 2 times 10 to the minus third. Got to square it. And what's R? R is 4 times 10 to the third, right? Agreed?
Yeah.
All right. Now what is that? Well, that's going to be 2 squared is 4. 4 times 4 is 16, right? And then I have 3 squared is what? 10 to the minus third squared is 10 to the minus sixth, right? Times 10 to the third here is going to be, I'm sorry, I shouldn't have said, I got 2 squared is 4, right? 4 times 4 is 16. This is what I should have said so you see it. And then I have 10 to the minus third squared is 10 to the minus sixth times 10 to the third is 10 to the minus third, right? And that would be watts. Do you all see that, class? Just show hands. That's power. You have to know how to do power. You could get it with voltage times current. The voltage is equal to 8. The current is 2 milliamps, so it would be 16 times 10 to the minus third watts. Same thing, right? Either one works. Okay? Everybody got that?
So that just be 16 watts or milliwatts?
Milliwatts, yes. Anybody want to tell me what the total power provided by the source is just based on that and some insight into what's going on? Anybody at all? Well, do you agree the same current's going through both of these resistors?
Yeah.
There's 2.
Do you agree that the resistance is the same?
Yeah.
Do you agree the power consumption should be the same?
Yeah.
Therefore, it'd be 16 milliwatts times 2 or 32 milliwatts. Agreed? And that would be the power provided by the source. Okay, next question. Thank you, whoever asked that. I know we went through it, but I think this might have helped.
Dr. McGinty, I have a quick question.
Yep.
Is it just a coincidence that the current we solved for was equivalent to the current source in the original problem?
Yeah, that's a coincidence.
Yeah, I just wanted to make sure that wasn't supposed to be a given or something.
No. It's a pure coincidence, and believe me, I didn't even think about that. At least people.
I have another quick question. When you find that Thevenin resistance, you turn off the voltage source and the current source?
Right, and turning off a voltage source implies a short circuit. Think of a battery with 0 volts. It's a short, right?
Okay.
And when you turn off a current source, no current can flow no matter what the voltage is, so it's an open circuit, or it's a cap pipe. Got it?
Thank you.
Okay. Now, other questions. I'm really trying to do justice to the Thevenin thing.
I was working problem 2.57 and
go ahead.
And I was using Thevenin analysis.
That's fine. But let me make sure we're all together on this, all right? I mean, you've got this in front of you, and if you have a printer available, I recommend you print the homework. That's my advice to you. That way you can reference it very quickly, okay? All right, now, go ahead, sorry.
So when you're taking RL, so once like the voltage across the, across the voltage source and the resistor.
Yeah, that's
So
tricky.
when you,
Let me do this, all right?
yeah,
All
I
right.
was,
Here's
didn't know I do that.
Here's the way you do it. And this is one of these things with engineers. They have to be able to see through things. You know, they have to go the step beyond the obvious. I know I could pull both of these out, right? You agree with that? But how about we leave the voltage source there and we just pull that out, all right? Call that RL. Got me on that one? Leave that voltage source alone. With me?
Yeah.
Y'all follow me on this? Because what do I know? Once I have this, I have the Thevenin equivalent circuit that thing's on, I can get the current through that, can't I, class? Y'all agree with that? How many agree? We'll do this. I want to do this one for y'all agree. And once we have the current through that, well, don't we have the voltage? Because we would have the voltage from here to here. It would be -6, right? And depending on the direction of current, if it's in the direction of I2, it would be -6 plus I2 times 1K. Do you see that? That would be the voltage from the negative to the positive terminal here. Do you all see that, class?
Can you say it again?
Yeah, and I'll say it slower. If I want V0, I can see V0 would be a decrease of 6, right? -6, correct? Plus, well, this voltage. If that I2 is in the right direction, it's positive, then it would be what? That would be positive, that would be negative. It would be plus 1K times I2 would be V0. How many see that? All right, now I'll do the problem. And it's a very good problem because this is one where it requires you to think beyond the obvious. And that's a typical engineering problem when you get, especially seniors. You're going to get that. You're going to get it left and right. All right, now with 257, we're going to do it. And I'm glad you asked this one. And we're going to assume that the load, as I've shown you, was 1K ohm. All right. So I'm just calling that the load. That's the first step. Now I'm going to remove that and take a look at what's left. Can you all follow me, class?
Yep.
All right. So what's left? Here I have 1K off to the left. All right. That's 1K ohm. And then I have 12 volts here. All right. And then I have 1K here. All right, and then I have 1K here. And then I have this. I've removed this resistance. Now I'm going to call this my plus to minus V open circuit here because I've taken that resistor out. Call that plus to minus, right? And I still have the 6-volt source right here that's minus the plus. 6 volts, and then it comes like that. And this is where the open circuit voltage would be, right? That's minus right there. You all agree with that, class?
Yes.
I want you to go ahead and write it down. Take your time. Now, next, what I'm going to do is solve. I've got that. I'm going to solve for V open circuit. So V open circuit, you don't have to do it in this order, but I choose to do it. When I look at this, well, what do I need to do to get V open circuit? First, how much current's flowing this way?
0.
Yeah, thank you. What's the voltage across this? This 1K.
0.
It's 0, no current,
0.
no voltage. You agree with that, class?
Mm-hmm.
No current through a resistor, no voltage across the resistor. The exception is if it's an open circuit. That's the exception. But we're saying finite value of resistance. All right, now we need the voltage. Now I want to show you this too. We can forget about that part of the circuit, can't we really? It's doing nothing. There's no current flow. Do you agree, class?
Yes.
Take a good look. All right, now with that in mind, you see how there's 12 volts distributed across two 1Ks in series? How many do? Agreed?
Agreed.
I got 12 volts to 1K. How much voltage is across this 1K?
12 volts.
6 volts.
6, right? 12 divided by 2. Do you agree with that, class? Give me a shot. I mean, it's okay to make mistakes, especially if you got 5 things going, like a radio talking to your friends, stuff. I know people probably watching Feinbaum or something like that, but that's okay. And what I'm trying to do is make sure you see this. Good? All right. So that's 6 volts, right? The current would flow out of the pot. And you agree that this is 6 volts, right? Everybody?
Yes.
Why is that one 6 volts again?
Okay, we have 2 resistors that are identical, right?
Mm-hmm.
They're in series, right?
Okay, yes.
Okay, good, everyone? Okay, now, look, I need this voltage, right? Plus to minus right here, correct? Y'all with me?
Yeah.
Now follow me. There's the negative terminal. Here's where I'm going to start. This is a voltage, what? Increase or decrease?
Increase.
Increase of 6, right? Came from a negative, left a positive. Agreed, class? So I get an increase of 6. Keep going. What happens here? I go from negative to positive, or anyone?
Increase of 6 again.
Right. So we have 6 and 6, or 12. Correct, everyone?
Yes.
How much here?
0.
0. It's obvious, right? So therefore, VOC is equal to 12 volts. How many see this? I'm glad you asked this question. This is a good question, a typical kind of question that would be on a test or quiz. Because it requires you to think. Got me on this one, class?
So why can you skip all the circuit to the left?
Well, I could go this way if I wanted to. Couldn't I get, this would be an increase of 6, right? And this would be a decrease of 6, right?
Okay.
So plus 6 minus 6 is 0, plus 12. And back here, I could go that way too. Doesn't matter which way you go.
So you're always following one loop.
Around any closed loop, the voltage sums to 0. If I go from here, I get an increase of 6, then an increase of 6, 12. Come over here, and if I went from here to here, I get a decrease of 12. So the sum of all the voltages around any closed loop is 0. So if I just want the voltage across one break in the circuit, I start at the negative, go around to the positive, and say that's the voltage across it. Yeah. Got me, class?
I'm a little confused as to why you don't have to count that second 6 volts.
Remember, the voltage across any closed loop is 0. Let's start here, and I'll just, Hunter, watch this. You agree this is minus 6, right?
Yes.
And this would be plus 12, agree?
Right.
So that's a plus 6, right?
Right.
So when I have minus 6 plus 12 is going to be plus 6, and this would be a decrease of 6, or minus 6 would be 0 back to this point. You see that?
Right.
Now, if you come here, I know the voltages around this loop or this loop are all going to sum to 0, right?
Right.
They're like pressure. If you think about pressure drops or increases in any kind of a piping, the sum of all those drops, if you go around the closed loop to the pump, is going to be 0, through the pump, I mean. So if you come here, this is an increase of 6, then an increase of 6 or 12, nothing or 0. So I have plus 12 between here and here, and therefore this is 12. And if I went through here, it'd be minus 12, which sum to 0. You see that?
Oh, yeah. I see what you're
Now,
saying.
if you go this way, it's going to be the same thing. It matters not what path you take.
Okay.
Got it?
Yeah.
Now we continue. That's the open circuit voltage. The next thing I need is, and help me out here, class, R Thevenin, right? So what is the Thevenin? What do I have to do now, class? There's one particular thing I have to do. Help me out.
You need to simplify the loop further down.
There's something I'm looking for specifically, class. What do I do now with the sources? You have to know
Take out
this.
the sources.
Short them out, right? They're voltage sources, right? These become short circuits, don't they?
Yeah.
Sources would be open circuits. Got that, everyone?
What subscript are you using for R Thevenin?
R sub TH.
All right.
All right, everybody hear that? Now, that means this is a short circuit, correct? And
Yeah.
that's a short circuit. They're wires, right? Now, what's the resistance between here and here? Take a look. Somebody got to this point ahead of me, but they said if that's a short circuit, then the 1K and 1K are in parallel, aren't they? Do you agree with that?
Yeah.
So that's what? That's 500 ohms or 0.5K, right?
Yeah.
So if I go from here, I got 0.5K or 500 ohms plus 1K or 1,000 ohms. So I have 1.5K ohms. Do you agree with that? How many do? Okay. Next, I'm going to build a circuit. So now my equivalent circuit has got 12 volts here, right? Then I have a Thevenin equivalent resistance here of 1.5K ohms, right? And now what I'm really after is going to be the current. And now I plug back in where I took it out, my RK, which is 1K, correct, class? You agree with me?
I'm sorry. How did you get the 1.5 kiloohms for the time?
All right, if you start the negative terminal, whoever asked this, right? I come around here, do you agree the 1K and 1K here are in parallel?
Yes, sir.
Therefore, it's 500 ohms or 0.5K?
Oh,
Huh?
yes, I understand.
All right, if that's 0.5K, that's in series with 1K, then you're back at the positive, or it'd be a total of 1.5K. You agree now?
Yeah. Thank you.
All right, so if that's 1.5K, now what's the current here? Because that's what I was after, right? Or the voltage, either one. I'll call that VL or the current. I would be what? 2.5K. Do you agree with that? Everybody? That would be the current. What would the voltage be? V load would be equal to what? 12 times 1K, right? Over 2.5K, right? Agree?
It should be 4.8 milliwatts.
I'm sorry, say that. What?
So I believe that would be 4.8 milliwatts.
That's a voltage. It would be volts, wouldn't it?
Yes, sir.
So this would be, is this 1 over 2.5? It's 2 over 5, 24 by 5. Actually, it would be what? VL would be 24 by 5 volts. Is that right, class? I mean, however you want to do it. Correct, class? Look, 2.5K over 1K is 1 over 2.5. That's 2 over 5, right? 2 times 12 is 24 over 5 volts. Agreed?
Yes.
Okay. I'm going to leave it as that. Now, finally, since that's the voltage here, now listen, the original problem, we've got the voltage across this little guy right here, this resistance, right? It's plus on top, minus on bottom, and it's 24 over 5 volts, correct? Can you all see this, class? Right? The resistance right here would have 24 over 5 volts. How many see that? We just figured that out, didn't we, class? Yes?
Yeah.
Okay, I mean, can you all hear me okay?
Yes, David.
You good with that? All
Yeah.
right, so now what's V naught? Well, it would be minus 6 plus 24.5, right?
Yeah.
Okay, so finally we find that V out would be what? V out would be equal to minus 6 plus 24 over 5. Now, I don't care how you do this. 5 times 6 is 30. So I'd have minus 30 plus 24 over 5, right? And that's going to be what? Minus 6/5 of a volt. Correct is V naught. Or minus what? 1.2 volts. Do you agree with that?
Can you repeat again why V naught equals -6 plus 24/5?
Okay. Now, you agree that that's not V naught, it's V load, right?
Yes, V load.
All right. Do you agree with this circuit I have here?
Mm-hmm. Yes.
All right. If I want this voltage, I take the source voltage, right?
Mm-hmm.
Well, and I multiply it by the resistance I want the voltage across, or 1K, right?
Yes. Mm-hmm.
And then I sum the resistances that aren't series. That would be 2.5, right?
Mm-hmm.
So 12 over 2.5 is 12 times 2 over 5, isn't it? 1 over 2.5 is 2 over 5, isn't it?
Yes.
So 2 times 12 is 24 divided by 5. Do you agree?
Yes. Mm-hmm.
Everybody? So tell me, is this minus 1.2 the right answer, whoever asked this question?
No, like my power supply.
I'm sorry, I couldn't understand you. Who asked this question?
I did.
Is that the right answer, Trevor?
Yes, it is.
Thank you. Okay, now what was the other, somebody else was saying something?
I was saying it's not the VL. Like, how did you put like -6 plus 24/5? That's
All right.
the question.
All right, when I came here, can you see this okay?
Yes.
How about now? Better?
Yes.
Huh?
Mm-hmm.
All right, start the negative terminal. We want this voltage, right?
Mm-hmm.
So this would be a decrease of 6, right?
Yes.
And this would be an increase of 24/5, right?
Oh, okay. Yes, I understand that.
All right, good. Okay, class, now I know I'm at 1:51. I'm trying to do due diligence here in answering questions. So it takes me a little time to answer everybody's question on Zoom. And I hear all sorts of people leaving and coming. It doesn't matter. Now, this is the official office hour. So on Monday, the official quiz will have both Thevenin and nodal and all the other stuff required for you to understand. What it's going to encompass, I'm not sure yet. I haven't made it up.
So you'll tell us which method you want us to use?
Yeah, I will. And if I don't, then you use whatever you want. You know, I mean, some are so easy, you just use whatever you want.
What program will we be using for the
What?
quiz? Or what program will we use to submit the quiz?
Oh, no, it's going to be submitted on Canvas. In a nutshell, here's what it comes to. You're going to get a quiz that you will, on paper, write the solutions for, and in the upper right-hand corner, you'll box your answers. Got that? And I'll have explicit instructions. Then what you'll do is take pictures of it on your camera. From your camera, you will upload it to Canvas, either by, and what I'm going to ask you to do is put it in a Word document. The reason I want you in a Word document, it's easy for me to grade and then put comments in there if I have. Got that? So, or my grader, I should say. But, and then I will be able to do justice to this. Now, I tell you this much, practice using your camera to take pictures of some stuff and then seeing how long it'll take to put it into a Word document and then upload it to Canvas. The reason I'm saying this, for everybody's benefit, and try to leave it in a Word document. Don't put a PDF in there. It's harder to grade. I know that, and I can't, it's harder for comments. The reason I'm saying this is some people have issues with technology that are almost unforeseen by me, but you may have them. I'm just warning you about this. People that use Apple products, people that use Red Hat Linux, any kind of, anybody that homebrews stuff, you may have problems that I don't foresee. So make sure you can do this quickly in less than 2 minutes for sure. That's my idea. If you have a page, 2 pages, you should be able to take pictures and quickly get them in Word easily and then submit it to Canvas. Now, from the time your submission is started is when it actually counts, but hopefully you'll have them uploaded by the time the clock ticks out.
And I assume you want us to take pictures with our phone and then
Yep.
put it on. Okay.
Yep, absolutely.
For the quiz on Monday, what homeworks will it reflect?
Everything. All of them.
All of them?
Oh,
One,
yes.
three, and four?
Everything is cumulative. You have to know the first sets of homework to do the last. Everything is included.
Okay.
Matter of fact, this is an issue I'm just going to cover right now, and I'll probably say it again. every single test and quiz is based on everything. Because everything builds. Have you noticed how you need all the information as V equals IR to do this? You need all the information from before to do these problems. Admittedly, you don't need nodal in the true sense of the word to do this one, but we did use nodal without even saying that to calculate the open circuit voltage. Okay. So that's the thing I want you to make sure you understand. Now, the next thing I'm going to cover, since this is my office hour, if you have to take a bathroom break, please go ahead. I'm going to take a sip of coffee, what's left of it.
So can you add a ground at any point while you're doing your Thevenin's?
You add a ground only one time if you want to use nodal analysis to do part of a problem, part of a Thevenin problem. For instance, for this one, right, I could put a ground here if I wanted to. But it does me no good because I really don't have to solve nodal equations where there's more than one path for current to come in and out, does it? Because I'm going to remove this, correct?
Yeah.
All right. Now, there may be a time when it will benefit you to do that. Then go ahead.
Okay. Add it on like, well, I guess you'd always add it on the bottom rail. So
That's, yes. And I'll say more about grounds when we get into power. Now, grounding for you mechanical engineers and aerospace engineers is going to become important. And I guess industrial engineers, if you are literally on the shop floor and doing work, then you'll have to understand this too, because if you're doing industrial processing for like West Point Pepperell or an active plant, then you really have to understand grounding. And I'll spend more of that when we get through power. Okay.
Can you do 276?
Yeah. It says solve problem 267 using Thevenin's. All right, now I'm gonna, you with me, everyone?
Yep.
Hope you all can see this. Here's 267. I'm doing Thevenin. I want you to listen to me. This is gonna be a little more, it's gonna be a lot easier than you think. First, what is the load? Anyone?
3K ohms.
Yeah, y'all see this right here? It's 3K ohms, right? So if it's 3K ohms, I first identify, I write it down, then I remove it, don't I, class?
Yeah.
Yep.
It's not there. Got it? Now, you know, my finger is a little big, but if that's not there, do y'all see how that 6 milliamps has to flow through that 6K?
Yes.
I want you to take a good look, people. You all see that? If it can't flow this way, it's got, so what's the voltage between here and here? Six milliamps times 6K is
36 volts.
36 volts. So I know this voltage, don't I? I'll just watch. Don't I know this voltage is 6 here?
Mm-hmm.
Take a look. Everybody see that?
Yes.
That's 36, right? And it's plus to minus 36. I don't want to write too much. And that's 6. So what happens if I want the voltage from the negative terminal to the positive? I get a decrease of 6, don't I? Who asked this, by the way?
Me.
All right. You see that, John?
Okay. Negative to positive is an increase, right?
Yeah, but I start the negative terminal, right? Right?
Yeah.
And that's positive to negative. That'd be a decrease of 6, right?
Yes.
Yes.
Now I come over here and I get an increase of 36, right?
Yes.
So it's minus 6 plus 36 or 30 volts, correct?
Yeah.
Y'all looking at, you understand what I'm doing here, right? Give me a thumbs up if you do. I'm trying not to waste time.
Yeah.
Yes.
30 volts is the open circuit voltage. Good. Now remember, that resistor is no longer there, right? The next thing we do is remove the sources. We're going for our Thevenin. Or well, actually, let's, we got the open circuit voltage. Yeah, let's remove the sources. So we turn off the voltage sources, turn off the current sources. There's a current source here. What happens to it, class? Anyone? In your own words.
Becomes an open circuit.
Yeah, it goes away is what happens, right? It's no longer there. Agree?
Yes.
Yes.
All right. That becomes a
Sure.
short circuit. That resistor is gone, isn't it?
Mhm.
Yes.
Now, how much resistance is between these two terminals? Well, I could go this way, but then I'd be back where I started, correct? That makes no sense.
Mm.
I go here, that's a short, and I see it's 6K. Y'all see how R Thevenin is just 6K right there?
Yeah.
Yeah.
Show of hands, how many see that? Or thumbs up, give me some indication of life, right? And understanding. You got it?
Wait, can you say it again?
Yeah, you see how this is a short, right?
Yeah.
That short circuit is in parallel with the 6K and 3K, so 0 ohms in parallel with any ohms is still 0 ohms, isn't it?
Yes.
All right, so I got 0 ohms here, and then I got 6K here, right?
Mm-hmm.
Therefore, you see how R Thevenin is 6K? Because that resistor is gone, isn't it, class? Right?
Did you have to do that specific loop through that?
Well, what other loop can I do? This loop I can't do, right? I could go this way, but it makes no sense. Why? Because this is in parallel with these two, and 0 in parallel with these two is 0. Equivalent resistance from here to here is 0 ohms, isn't it?
Yeah.
Colin? You see what I'm saying? That's 0 ohms. That's a short circuit, right?
Yes.
Short circuit in parallel with anything is a short circuit, isn't it?
Oh, okay. I see.
Okay, so I go from here to here, it's 0, and that's 6K. So R Thevenin would be 6K, correct?
Yes.
Then you draw the circuit. Now I'm going to draw the circuit. So you would put 30, right? Sorry, 30. And then you would put R Thevenin, which was 6K, right? Agreed, class?
Yes.
Now I put back my resistor, correct?
Yes.
And the resistor was 3K. What did they want? They wanted V out, didn't they? Yeah. So what is this? What is V out equal to? And I'll take it from anyone.
$10 volts?
Well, how about we write the, how many see, you're probably right, but how many see that this is voltage division? Y'all see that?
Yeah.
It's simple voltage. Sure, you take 30, right? And then you multiply it by the resistor. You want the voltage across, which is 3K. And you divide it by the sum of 3 and 6 or 9K, right? Whoever said 10, you're right. You're ahead of me. And therefore, V out would be equal to simply 10 volts. Do you all agree with that?
Yeah.
This is straightforward, and it's, I want to just level with you. This is fairly easy if you do the homework and keep up with it. But I warn you again, this class builds on every concept, and it assumes you have a very good understanding of every concept. In another week to 2 or 3 weeks, if you don't thoroughly understand this stuff, you will be nearly completely lost with the next. You won't even know what to ask. So I cannot tell you enough times, you've got to keep up. And I'll make it something real to you from what your past. You remember when you had dynamics, right? Some of the moments equal the angular, angular acceleration, right, times the moment of inertia. Some of the forces equal the mass times the acceleration. Well, if you didn't know statics, then you surely can't do dynamics. And it's the same thing here. Got it? This stuff is like statics. Dynamics is coming, if that makes sense. It's not an exact analogy, but it'll give you something to think about. Y'all had dynamics by now, haven't you?
Yes.
Okay.
Doesn't have to take it.
What,
Not my curriculum.
What's your major?
Materials engineering.
Okay, well, it's too bad. It's a great course. The only course I regret not taking as an undergrad was a formal quantum course. I ended up in graduate school taking plenty of quantum, but that was the only one I missed. Okay. That and organic gardening. I never took that. Anything, now, what other questions do you have?
I have a question. So how do we choose what is going to become our RL? Because in this problem, why did you choose 3?
All right, I want somebody else, if possible, to answer that question for me. Anybody?
The voltage the question is asking for is the voltage across the 3 ohm resistor.
3K.
Or 3K, 3 kilo ohm resistor.
Right there.
So you want the, so that becomes your RL.
The unknown, where the unknown is either current or voltage, whatever element that is, that is your Thevenin, that is your load resistance part, your load resistance. Okay?
Mm-hmm.
Good. What else, guys?
I had a question about how we're going to be dealing with people with COVID, but I can wait till we're done with all the problems.
Yeah, sure. We're going to probably allow them to get over it, and then they're going to take the quizzes they missed in person. Okay.
Is there a deadline for when they need to have test results sent to you or anything like that?
What's going to happen is I have to have an official test result. I have to now. And it's got to be something that they're making absolutely sure that anybody says they have COVID. In fact, they do have COVID. And if they don't have COVID and said they do, then it's basically one of the things. I don't know. But I'll let Fred Cam. He's told me that there's a lot of, I guess, fake COVID stuff. And they told me about this. All these kids are in so much trouble right now. They don't even know it. But God help you. They've got it. Everybody looking into this. I didn't do it. I didn't know there were laws that you break when you do that.
That's truth.
I don't know what laws pertain, but I know something about the pandemic and the national health crisis make it. I don't even really want to touch this now, but I'm just going to wait for the information to come forth. But I got an earful from people about this in the administration. So enough said about that. Let's focus on this.
They're paying so much money to go to Auburn, though.
They can pay so much money for a lawyer to get out of jail, and that's up to them. Anyway, back to this. Let's just keep focused here. I don't know what's going to happen. I'm just, who knows? Back to this thing. When you're clear with COVID, then you come and take your quizzes that you missed. Got it? And it'll be official. And Fred Cam, if you have any questions, send it to him. He'll answer it. He's now actively involved in this class. And so is the provost office. You're probably watching this lecture.
How do you spell his name?
AAM. I think I sent people an email with that on it, though. I think, right? Or am I wrong? I'll get you the information. Don't worry about it. He's the medical officer of Auburn University. Okay. All right. Now back to this. Back to this stuff. What other questions do you have related to this?
Can you do 2.71 using Thevenin's theorem?
Yeah, be happy to. 2.71.
Yes.
All right. This is a problem. It's a good problem. Find VO in a network. So what they want is this voltage with, let's talk about this, whoever asked you. Good problem. First, we have to locate the Thevenin equivalent, or the Thevenin load, right? The load resistance. Which one is it?
3K ohms.
Yeah, and I'll try to zoom in for you.
Thank you.
So this is 3K, right?
Mm.
Now, we remove that, don't we, class?
Yes.
So that goes away. Next, we have to find the open circuit voltage, correct?
Mm.
I can draw this if you want me to, but look at this for a second. If this resistance is gone, how much current is flowing through that 3K right there? Say again?
0?
0 amps. Do you all agree with that?
Yes.
Yeah.
So if no current's flowing this way, then I look around this circuit, that 4 milliamps has to be flowing this way, doesn't it? Please take a look. Everybody take a good look at this. Got that? So the current's flowing this way, correct?
Yes.
Now, if the current's flowing this way, what's the voltage across this 6K ohm? 6K times 4 milli, right? It would be plus to minus what? 24 volts, right?
Yes.
So there's 24 volts across there, right?
Mm-hmm.
How much voltage drop is here? Come on. Remember that resistor is gone. How much voltage drop is here? Across that?
0.
That's what my point was. So if I see there's 24 volts this way, now look, Here's the negative terminal, right? Where, Jessica, is that you who asked it?
Yes, yes, sir.
All right, there's the negative terminal, right? This is a decrease of 12, right? Minus 12. This is a decrease of 12, right?
Yes, sir.
How much is that? That's minus 24 to this point, right? This is a what? A decrease of 24, agreed?
Yes.
So that means I have minus 48 volts here, right? Come on. Minus 12, minus 12, minus 24, minus 24, minus 48, right?
Yes.
Yeah.
Therefore, the open circuit voltage would be minus 24. Do you all agree with that? Show of hands here. I'm not trying to go too fast. Jessica, you got it. Everybody? Okay, good. I'm seeing hands and thumbs. Thumbs got me on that, guys? Calvin, can you see this okay?
Yes.
I'm just making sure. 'Cause I'm looking at people and I see people squinting. All right. Once I have that, I've got minus 48 volts. Now I need R Thevenin, right? I'll redraw this in a second. Agree?
Yes.
All right, that's gone, right? What do I do with this source?
Short.
Short, right? It's a voltage source. That's a short. What does this become?
Short.
What does this become?
Open.
Open, right? So I go from here, short, I hit what? 6K and then 3K or 9K. Do you agree with that?
Yes.
Show of hands. How many see it's 9K? Right? All right, now I draw the circuit. I'm going to draw it over here. I hope you all can see this. So now I have, remember, it's negative, and I'm going to draw this with a battery. All right, I'm going to just show you. With a battery, the negative terminal is the short one. This is the big one. This would be minus to plus, and it would be 48 volts, right? Remember, it was negative. It was negative cents for the positive, right? So you put the negative on top.
Can you move a little bit down?
Oh, I'm so sorry.
Oh,
Thank
you.
You all with me on that?
Yes.
Now I come over here and what happens? I put the resistance in series, right? And what was that again? 9K, right?
Yeah.
Isn't that right, everyone?
Yes.
9K ohms. And then what do? I put the plus, minus here. That's my Thevenin equivalent circuit for any load, correct, class? All right, what do I do at this point? I put in
Your RL.
which is see, I'm looking for a number. So,
3K.
3K, thank you. You're right. Okay, and what do they actually want there? They want the voltage, right? They want this, plus the minus V out. Anybody want to take a shot at that and get the polarity right? Justin, you look like you're ready to talk. I don't know if you can see his picture, but it reminds me of somebody I saw before. Maybe he's not there. That's all right. Anybody want to tell me?
Negative 48 over 3.
Well, okay, but let's do the whole thing. I take the voltage source, minus 48, right, class?
Yes.
All right, so minus 48 times
Isn't it
the load.
3 over 9?
Right, 3K, the resistor over
9.
12K.
12, thank you.
Yeah.
Right? So I have 3 over 12 or 1 over 4, right? 48 by 4 is 12, right? Minus 12, actually, right? So V out is minus 12 volts. Y'all agree with that? I know some of you can do these problems in your head. I've got some very, very bright people in here. They whiz through this and it's sort of a joke, but some can't, and that's the reason I'm slowing down. So don't send me emails about, you know, how can you go so slow?
Is the negative 12, is that relative to the source?
It's relative to the minus and plus terminal, right?
Okay.
Y'all with me on this? That means if I put a voltmeter here and I measured plus to minus with the leads, plus on plus, minus on minus, I would get minus 12.
Yes.
Got me on that? Good. With me? Okay. Another question. I hope this is still being recorded. It looks like, is it still being recorded, guys? I can't tell.
Yes.
Good.
Yeah.
Good. Excellent. All right. You got another one for me? I didn't get to mesh. I was going to today, but I didn't. Anybody?
I have a question about accommodation.
Oh, okay. All right. Let me just make a statement here. If you need extra time, if you need a quiet place to work, whatever, all right. When we have in-person testing, you will arrive and go through the class with me, and then I will take you after class to Brown Hall, away from Brown Koppel, and you will get your accommodations there. Now, on Monday, because you will get this one remotely, I'm reluctant to do that, but I said I would, so I will. You're going to get remotely, and those of you that get extra time will be given extra time to hand it in, whoever asked that question. I assume that's one of the questions. The second thing, if you require a quiet environment, it's up to you to find a quiet environment if we're on Zoom. I can't provide that.
Okay.
And if you have specific questions, send me a message and we'll deal with that. If you, for whatever reason, I don't know, your internet's spotty or whatever, I don't know how to tell. You know, I had one person had, believe it or not, a storm come through. I don't know if it's a tornado or what, destroyed the internet in the area. He had to go to a Starbucks or something like that to go ahead and take quizzes. This was in spring. He was a good student and stuff like this. It wasn't his fault, but it just happened. He was down in Enterprise, Alabama, I think. If you know where that is, South Alabama. Anything else, guys?
I have a question. It's very simple and silly, but
go. No, there's no dumb or simple or silly questions unless you're going to ask about football.
So the VO that you just did, what is the exact formula that you use?
I'm using, this is voltage division.
Oh, yes. Okay, never mind. Yeah, I got it.
Okay.
Thank you.
All right, and let me make one other comment. All right, now I know I got some very, very bright and good students in here, some extraordinarily bright and good students that have been sending me little bits and pieces, and some people who have told me a whole lot of information that I really care about to know about the class. And apparently they told me in administration all this. Now, I don't know what's coming down the line, but please be cooperative, and I don't know what they're going to do to people. And frankly, I can only tell you that everything that has been said and done is a matter of record. And now I've got a whole bunch of people looking at it from every angle. And I haven't got law enforcement to call me yet, but I'm expecting it. So whatever you do, tell the truth. That's the only thing I can give you advice on. Just tell the absolute truth, because God helps some people. God help you. All right. Now, that's enough of that. I don't want to answer any more emails regarding things related to other stuff outside of my control. But regarding this, I think we've covered this fairly well. We've covered nodal, we've covered Thevenin, we've covered voltage division, current division, power. We've covered, in my opinion, a fair number of problems. If somebody has an issue, a question about any of this stuff related to any of the problems in this book or other books, let me know. Okay. As a matter of fact, I'll show you, if I can, what quiz I had planned for you today. And it was a relatively trivial one. It's unfortunate we didn't get to take it. You're going to kick somebody for this. If I can find it now.
Are the quizzes usually similar to the homework problems?
Well, they have resistors. I mean, yes and no. Yes, yes. They require the same concepts. No, they're not an identical problem, if that's what you're looking for. I mean, yeah, they're made of resistors, all right, and source voltages. So, but is it an exact? No. I don't know how to answer that. I mean, yes and no is, I guess, my best bet.
Like, if you can do the homework problems, will you be able to do the quiz? I think.
If you understand the concepts. In other words, don't say that you didn't put that one in the homework. Yeah, I know concepts are identical. That's, I suppose, what I'm getting at. Because I have people, oh, you never gave us that. You're right. You're right. I used 3 resistors instead of 4. I'm sorry. But you can't, you know, guys, if you're engineers, you know what it's like. You know what's coming? There's nothing that you haven't seen. And I mean, you guys are bright. There's extremely bright people in here. Give me 1 second, I'm trying to find it. Oh. Okay. All right, hang on. Hmm. Give me 1 second. So it's pulling it up, and I don't know why it's not resonant here. Oh, now I see why. All right, here it was. We can do it together. This is, you ready?
Yeah.
Can you all see this, class?
Yeah.
It was trivial too, in my opinion, but and probably in yours too. Now, if you look at this one, I want V1, right? So this is what Kirchhoff's current law. This is a node, isn't it, on top here, class? Whatever goes into the node comes out of the node, correct?
Yeah.
4 goes in, 2 comes this way. How much is going through the 7?
2.
2, right? 2 amps. 2 amps times 7 ohms is?
14.
And it's 14 volts. Yes. Right? All right, go here. All right, I want this voltage, right?
Mm.
Now, you all agree the 3 and 2 are in parallel?
Mm.
Class?
Yes.
All right. Don't worry, I'll give this to you. You don't have to copy it down. This is a quiz in person. The one you're going to get is going to be quite a bit different. Much different. Much harder. All right, for this one, you got 3 and 2, which is what? That's 6/5 of an ohm, right?
Yes.
6/5 of an ohm, that's 2 ohms, right? If I want this voltage, isn't just 6/5 of an ohm over 2 plus 6/5 of an ohm times 16. Do you agree with that?
Yes.
All right, what's that? I'll put it here. I'd say V2 is equal to what? 16 times 6/5, right? Divided by 6/5 plus 2. Agreed?
Yes.
All right. So 2 is really what? 10/5, right? So 10/5 and 6/5 is 16/5, right? So I have 6/5 over 16/5, or 6 over 16 times 16, right? 6 over 16 times 16 is 6 volts, isn't it, class? Do you agree with that?
Yeah.
Where did the 6/5 come from?
Well, 2 times 3 is 6. 2 plus 3 is 5, right? They're in parallel.
Yeah.
You could do it that way, or you could take 1 over 1 over 3 plus 1 over 1 over, plus 1 over 2, which is what? Is what? It's 1 over 6 over 5, or 5/6 of an ohm, or 6/5 of an ohm, right? I mean, you all see what I'm doing here? This is just in parallel, right? Whoever asked that. Are you
Yeah,
with me?
I
Okay.
see it.
Okay, good. Now, what's this one here? This is good. All right, now think about this. I mean, this is honestly a trivial problem. So what can I do with these two? Remember, I want this voltage. What can I do with these two, anybody?
Just
Parallel, so
parallel divided.
1 k ohm, right?
Yeah.
1 k ohm. You see that voltage source, I could take where it is and just put it over here, right?
Mm.
So I have 6 milliamps in parallel with 3K. Then I have 2K, and then I have 1K in parallel with 4 this way, right?
Mm.
Y'all see you can do that problem fairly quickly? Class?
Not really. Could you go through that again with me?
Sure. You see, I have 6 milliamps, and this is 3K, right?
Yeah.
Then between this node, call that V1. Sorry, I'm trying to get this right here. V1 here. Right?
Yeah.
And this is V2, right? Right?
Mhm.
All right, now look, isn't this just 4 milliamps straight down to the ground? You might as well ground that whole bottom rail, right?
Yeah.
All right, now, if you look at this, current here is V1 over 3K, right?
Yeah.
Current here is 6 milliamps. Current here is V1 minus V2 over 2K, right?
Yes.
Current here is just V2 over 2 or over 1K. Take the 2K and 2K can make them 1K, right?
Yeah.
From here to here, the current source is just downward is 4 milliamps, right?
Yeah.
Can't you write 2 equations fairly easy and get 2 unknowns and solve for them?
Yes. Yeah.
It was a trivial problem, is what I'm getting at. If you would have had this in class and you would have done, this would have just been a trivial quiz. The one you're getting on Monday is not going to be trivial. I can tell you that. So I'm just telling you, I tried to do you a favor, but it didn't work. So
Can we have it like, I'm sorry, can we have it optional where people that want to take it in person, take it in person?
I really wish that could have been available. I don't have that power. Everybody gets the same opportunity, the same method. Now, I wasn't involved in all this stuff, by the way. I mean, it was out of my control, so to speak. We're going to go back to it in person after this one for as long as we can. With me? And I'm sorry. I wish this didn't happen. I'm sorry about your bad apples out there that caused all this. And I don't know what's going to happen. I hope they're not in too much trouble, but I'm not the person that is going to have to deal with it. I've got other problems right now. Are you all with me, class?
Yes.
All right. Remember, if you're contacted, tell the absolute truth. Just remember that. By anybody. Anyway, getting back to this class, I want to say this. I've given you the solutions for every problem in that chapter. If you look online, there's a cajillion other problems you can look at that have the solutions. They're all over the place. You can look at HAYT, H-A-Y-T. You can look at the MIT guy, whatever his name is. You can look, and there's so many things out there. There's references all over the place. If you go to MIT online, they have an online course. You can see what they've given you. You can go to Stanford, I think they have it. There's so much material out there. What I suggest is you do what I told you to do first, then work on supplementary material. If you have questions, ask me, okay? And I'm just trying to be fair about this. I want you to be serious about it. Maybe I try to scare you too much. I don't want you to think you can coast, because what's happening, it happened in the past. I got kids that are brilliant, like 1490 kind of ACE or SAT. They're almost perfect ACTs and stuff like this. They come in here nonchalant and they wait, and then they flunk the course. And it always happens because they basically relax when they should be serious. You do what you're told, you'll do well. All right. Other questions? I did enjoy some of the comments people sent me. There's some very clever people here too, I found out. And I appreciate it. Does anybody have any other comments or for the good of the group, or any questions or anything else?
I have just a general question for clarification. Why do you feel that you need to make this quiz harder?
Oh, it's because you're going to have open book, open notes.
But I thought you said there wasn't going to be enough time to really even look at your notes anyway.
You will have them in front of you. If you know anything about students, you know that they look ahead. You'll have people that literally photograph every equation. They'll have all stuff. You won't believe what you'll see, what I'll see. All right. They're made at the level of proficiency. And when you get open book, open notes, it's a general rule of thumb that they become an order of magnitude more difficult.
Okay, so essentially we're
Graduate
making
school
this
and
harder.
undergraduate school. So when you get it in person, you don't have open notes, open books. So the thing is more direct and simpler.
So it's open book because you feel that everybody
Not
is
I
going to
feel,
cheat,
because
in your
the
opinion.
actual fact of the course is this. I mean, I don't want to be parsing things, but anytime you have everything available to you, you assume the students know the equations. That's an assumption that you should have right in front of them. You assume the students understand the previous problems. They're going to have the answers right in front of them and the solutions and the solution method. You assume they're going to try to compare your problems to what's available. You know that, right? That's a given. So now you make problems out that are based on concepts, so that if you understand the concepts, you'll be able to do them. But if you're going to be looking up things, just trying to find similarities and patterns, you're going to waste a lot of time. That's why I say they're more difficult. People that know what they're doing will whip this thing out in no time at all and have it done, and it'll be simple. People that are unsure or clumsy, they get hurt really bad in online tests, or I should say in open book, open note tests. And this has been at the graduate level. When I took courses too, I had one professor who was absolutely brilliant, used to say, well, if you choose, do you want open book, open notes, or do you want closed book, closed notes? And he just said, the open book, open notes are much more difficult. In terms of the conceptual facts are now going to be, they're going to be asked in a way that you're going to have to really figure things out. You've got to know what you're doing, be able to figure it out. And some people just, they don't spend enough time, so they have that level of confidence.
Okay, got you. Thank you.
But they're fair, trust me.
Okay, yeah, it's just, already kind of a hard class for a lot of people, though you say that a lot of these are trivial, sometimes they're not, so I was...
Well, I don't want to, I say this sometimes because of the comments I get. All right, many people have told me this is very simple, and I'm just leveling with you. I mean, at the end of the course, I've had this from all people, but I have others who have struggled. Oftentimes, some of their struggling is they don't spend time, but in some cases, they're just not exposed to this level of this type of stuff enough. They're in different areas. They might be in, I don't know, fiber engineering, or maybe industrial doesn't, with a focus that's not on this analytic stuff. Got it? But if you can do the homework problems without much trouble and you understand, you should have no problem at all. Okay.
So what you're saying is it's kind of like thermo, where basically the hardest you're doing is basic algebra, the hardest math you're doing.
Yeah, that's right.
But,
well, linear algebra.
Yeah, but it's not actually hard. It's...
No, as a matter of fact, I have not taken Birch's course, but I've taken thermodynamics at a high level. Anytime you're dealing with this course where you just have steam tables, what's the big thing? You got to know how to use the tables, right?
Yeah.
It's that. It's not the concepts. And I don't like steam tables. And you can quote me on that.
Yeah, they suck. Taking Birch right now, by the way.
He's a brilliant guy. He's a very good teacher. One of the best teachers you're going to get.
He's got a rock solid internet connection.
I'll tell him he says. He's, if you get a chance to take Birch, beware his quizzes are multiple. I mean, his tests are multiple choice.
I've heard that for years. He's finally had them now.
I mean, but that's the thing. If you know what you're doing, you'll kill that course. Really.
Well, yeah, but when there's, 3 methods to solve a problem and all 3 are part 1 of multiple choice answers, it's a little harder than it sounds.
Well, now I can't speak for Birch's I can't say that his problems have no way you can confuse him, the answers. So I'm not, but I can tell you this, he does a good, from what I understand, he does a very good job lecturing, delivering lectures. And unfortunately, people generally don't care for that multiple choice stuff. That's just what I hear. Yeah. But I like the guy. He's a super guy.
Of all the thermodynamics teachers I've had, he's been up there with Reagan. He's the 2 best lecturers I've had.
Glad to hear that. I don't know how you feel about this course. I've got a variety of backgrounds here. I've got the broad background. I try to deliver this material as best I can for everybody. And I know people are going to yell at me, you're going too slow, it's too simple, la, 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 la. And I get that all the time, but I have to do it at this rate in order for everybody to understand. And that's the reason. Now the Emmys really hammer me too. They are ruthless. I don't think they have a compassionate bone in their body sometimes. Like, we're not idiots. Okay. Enough. I don't know who teaches you guys, or if you're used to a lot of like, you're not idiots. But man, you're brutal on the professors.
There are times when you really wish the teacher treated you like an idiot, though. You guys know how to do partial derivatives, right? I'm not going to cover that. Moving on.
That would be Birch. Maybe, I don't know. Yeah. I try to be fair about this, you know, I really do. All right, any other questions related to the course? I'm sorry, I'm getting off track. John?
Yeah, I talked to you on Monday just about like being able to take next Friday's quiz on Wednesday. Is that?
Yeah. Next Friday's quiz, right?
Yeah.
Yes. Could you talk to me Tuesday? Just send me an email. We can talk via phone, okay?
Okay, sounds great. All right.
I have to check on something. Just
okay.
Okay.
All right, thank you.
So we're gonna have a quiz on Monday and then on Friday of next week.
That's the plan as of right now, barring another bizarre turn. Who knows what's going to happen? But yes, that's my plan.
Okay.
All right, Jessica. Now listen, I didn't mean to scare people. I'm just trying to make people serious about this. And a lot of people blow this off until like Sunday night. I really do mean that too. I hate to say it, but they do. I mean, literally, I have people that start studying for this at like 11 o'clock Monday for a 1 o'clock quiz. And they send me all these questions and they expect me to answer them all. Sorry. Okay.
Yeah, thank you.
All right. What's your major, Jessica?
Industrial engineering.
Well, I tell you, you have the longest name I think I've had in 5 years. Are you from Brazil by any chance?
Portugal is
Portugal. All right. Well, Brazil speaks Portuguese. I had a kid in it, one of the most brilliant students I've ever had. His name was Felipe or Luan Felipe. He had like 4 other names. And I don't know what it is about naming down there, but you don't do like first, last, and middle. It's like first, second, third, fourth.
It's because they put both our parents' name. You have your dad's last name and also your mother's last name in your name.
Okay. Well, that makes sense. I'm glad you told me. So you speak Portuguese then?
Yes, sir.
Okay. And you speak English. What else do you speak?
French and Creole.
Most of the time, people from Europe speak at least 3, sometimes 4 or 5 languages.
Right.
I wish I did. I have a hard enough time with English. If you're from Portugal, have you been here the whole time, or did you have to get permission to come here from the government?
No, I've been here the whole time.
Okay.
I didn't leave this summer. Yeah.
Okay. All right. Good. Because I don't know what's going to happen with this COVID thing. I really don't.
Yeah, that's what they said, that if you're taking only online school, then you have to leave, but then they changed that because I think Harvard and MIT went to the court about that. So they changed that for international students. Now you can take all online classes and still be here.
Well, that's fine with me. I think a lot of people are they don't know exactly the best way to deal with this whole problem. I know some countries like Israel won't let anybody in that's not literally an Israeli citizen. And there's other countries, I'm not sure what China's policy is these days, but everything's fluid right now. But stay safe, please. Don't go into bars and restaurants if you don't absolutely have to. Wear a mask.
I haven't been to campus since school started. It was only for your class that I was going to be going to class and coming back. Yeah, I've been trying to stay as safe as I can.
And you know, what I really hate to say is this: in my prior classes this summer and in the spring, I did have kids that caught COVID. None of them got seriously ill, but I have heard of some very young people even dying from it. A 25-year-old in Montgomery who was an ex-football player died from it, and he didn't have, as far as we know, pre-existing conditions. And when I was in the hospital, the thing that really struck me about this virus is I had some of the nurses who were very, very troubled by the COVID ward, which was on the 7th floor, and I was on the 6th, and they told me, you know, in their moment of, I guess, I don't know, weakness, tiredness, whatever, they just, when I was asking about this, they said, you know, we got 20-year-olds dying up there and nobody's talking about it. And I thought, really? Well, they should be. Now, I don't know anything more than what I was told, but it scares me that a lot of the stuff that happens to young people go unreported for whatever reason.
Mhm.
I hope you all stay safe and well. And I don't even know, have they closed all the bars downtown and restaurants or not?
I don't know, but I hope they do. I feel like they should have done that before school started.
Restaurants are open.
Yeah.
If it's just takeout, fine. But,
Yeah.
you know, when you get people congregating, that's where problems originate, really.
Exactly.
And some of these restaurants that have every other table, it's not 6 feet between the tables. They're
Is
too
that right?
small.
Yeah.
Well, I don't do that. My wife and I have been, I take it back. I don't go into restaurants, but I did get takeout from Fratelli's. It's an Italian place off College, and these two guys are from Rome, and God, they have some Italian dishes that are to die for. Oh God, and I love Italian food. This is a problem. But I did it. I'm not doing it now. I think BurgerFi has takeout too, if I'm not mistaken.
I think pretty much every place is doing some version of takeout, but some of them are also doing dine-in.
Don't. And if you get takeout, here's a tip, and I'm not a medical expert, so you need to qualify this with somebody is, if you microwave stuff and bring it to a, whatever it is, 185 to 212, somewhere in there, for like 5 minutes or something, it'll kill any kind of virus. It'll get rid of it. And that's a very good go-to if you have a pizza that's cold and you wonder about if the driver sneezed in it.
Yeah.
Just saying. I've learned to be suspicious after hearing some stories. You know, you guys are hanging out. Do you have other, I mean, are we done here? Any more questions about technical matters or? I don't care. If you can tell me anything that'll help me deliver this lecture, please do. Any recommendations?
Okay, so I'm scared that maybe school is going to close and then all the quizzes are going to be a little bit harder because we're going to have to take it online. I don't know. I know this is a class that requires writing and all of that. I don't know how this class can be done through like honor lock or any, if I would prefer we have honor lock or something like that, as long as the quiz is not really hard. So
I'm not gonna use honor lock, but one thing I don't think I am. Maybe I'll have to, but I'm just gonna tell you this, all right? Now hang on. All right, and I'm not trying to scare you, so just don't take it that way. All right, now you see this problem right here?
Yes, sir.
Can you do that problem fairly confidently if it was thrown your way, if you didn't see it?
Yes.
Do you feel that way, Joseph?
Yeah.
Jeannie?
Yes, sir.
James?
Yes.
Then you won't have trouble. Now, you think I might be joking, but if I gave a problem very similar to that, maybe reversed it, put the source on this side, flip the whole thing, and changed a few values. So identical structure, different value of voltage and resistance. And as for the same things, just via, you would be shocked how many people don't know where to begin. I'm leveling with you now. You've been around. You know what can happen to students on weekends where there's parties and distractions. And I'm not kidding. Now, not all of you, maybe 5 to 10%, but you'll be shocked. If you're keeping up, see, when I hear that kind of talk from you, Jessica, I can tell you're serious. You're a little bit paranoid because I probably made you that way. You're not going to have a problem. The people are going to have problems are the ones that are blowing it off. Oh, I got this. It's boring. They'll have real problems. You'll see it. And it won't matter how many times I warn them. I can warn them till till Armageddon. It won't matter. They will completely ignore it. They never learn.
Well, I think I'm caught up on the homework, but for this past week, I moved in the day before classes started, like on Sunday before classes started, into a pretty terrible apartment. And so I've been fighting maintenance requests, figuring out how to get internet set up, fighting to get them to get somebody to come fix my AC for like 3 days, where it was like 88 degrees in my apartment.
Oh God.
And finally I got all that sorted out, but like that was my homework time. I'm spending 5 hours filling out maintenance requests.
You okay now?
I filled out the maintenance request. No one's showed up, but
You still don't have air conditioning?
no, I got the air conditioning kind of sorted. Kind of. It wasn't like they still never sent anybody out. They said, let it thaw for 2 days. They never sent anybody out. And they said, well, try turning it on again. Well, it turned on again, and then it froze up on its way to 72. And then it said, oh, let it thaw again. This time, turn it down to 75 first, then 73, then 72. Like drop a degree an hour. Now it's fixed. And it's.
Get a lawyer soon.
I hate these people.
No, don't hate them. They're honestly, I've learned my lesson in life. Don't hate anybody. Really. I'm kidding you about it. I know I've had problems in my life too with apartments and places I've stayed. But you know, in the grand scheme of things, you're coming out of it okay, right?
Yeah.
All right. I assume everybody else is too, and we just have a small collection of people here. I'm going to have to get going. It's getting on towards 3. If you need me for anything, let me know. And remember what I told you. If you're contacted by anybody, be absolutely honest, because they are involved with something that I am not directly involved with, but I'm going to be asked questions. So that's all I can tell you.
All right.
All right, guys. Take care. Stay safe.
Have a good